The unit we're working on is all about polynomials, right? And this video is going to cover some of the vocabulary that you need to know as we dive into polynomials. All right, so first, let's talk about what a polynomial is. All right, here's our definition. A polynomial is an expression consisting of variables, constant coefficients, and positive integer exponents that involves only the operations of addition, subtraction, and multiplication. Right, that's a lot of pieces there. So go ahead and pause and make sure you have that definition in your notes. All right, now that you've written that down in your notes, let me give you some examples. I think this will really clarify for you what a polynomial is. All right, so here's the same definition again, but I'm going to give you some examples. Right, so what's a polynomial? Right, so here's an example of a polynomial. Right, something like this: 5x squared minus 3x plus 7. Or maybe something like this: negative 4x plus 7x cubed. Or something like this: 10x to the 4th minus 12x to the 6th plus 3x squared, maybe. All right, so you've dealt with polynomials before, right? But you need to know, what that term means as well, right? So let's kind of break down our definition again, right? We have an expression. We've got 3 examples here of polynomial expressions consisting of variables, right? We're using standard x here, constant coefficients, and positive integer exponents. All right, so the exponents, that's pretty obvious, right? This term here, constant coefficients, right? You should hopefully be familiar with that. But what are the coefficients, right? The coefficients are these numbers, right? This coefficient of 5, this coefficient of negative 3, this coefficient of 7, right? Those are called the coefficients, right? You need to know that word, okay? All right, and again, you can see how the rest of this is not that hard to understand, right? You've got addition here, you've got subtraction, you've got multiplication here, right? So basically, we have variables, we have positive exponents, we have addition, subtraction, multiplication. Okay, and that's basically what a polynomial is, right? The examples I gave you, this one has what we would call this a 3-term polynomial, right? Sometimes we call that a trinomial, right? This is the first term, second term, third term. The second one I gave you, this is what we call a binomial, right? There's 2 terms, this term and this term. Okay, so that's also something that you should know, right? This is called a binomial, right? This one, because there's 3 terms, that's called a trinomial. Okay, all right, so you need to be familiar with those, and I think you are pretty familiar with that. Let me give you some examples of things that are not polynomials. Let me scroll over here. All right, so you'll notice that in our definition, right, we can only use addition, subtraction, multiplication, right? So, and we can only use positive integer exponents. So anything that doesn't follow that would be something that's not a polynomial. So something like this: 5x to the negative 3rd plus 2x to the 4th, right? We don't consider this a polynomial because we have a negative exponent. Also, if I had something like this: 3 over x plus 4 plus 5 over x squared, right? Because we're dividing by our variable here, right? That's not considered a polynomial. Okay. All right. Something else that you'll hear us teachers talk about is the degree of a polynomial. So you need to know, you need to be familiar with that, right? Here's what the degree of a polynomial is. The degree of a single variable polynomial is equal to the highest exponent that appears in the polynomial. All right. Go ahead and pause and write that down. All right, this is a pretty simple idea. And one thing I want to point out is that the definition I'm using only applies when we have a single variable in our polynomial. So if there's multiple variables, this doesn't apply. But we're not really going to spend too much time on a multivariable polynomial, so I'm not really going to get into that right now. Okay? But to find the degree, it's basically that it's equal to the highest exponent that appears in our polynomial. So I've got 4 polynomials here. This first one, this has a degree of 2, right? Or we might say a second degree polynomial, right? Because the highest exponent is 2. Okay. All right. Number 2, 5x minus 1, right? This one, the highest exponent is a 1, right? Because it's x to the first power. So we would say this is a first degree polynomial. All right, the third one, this one, what's the highest exponent? Right? Well, that's the 3 here. So this is a third degree polynomial. All right, the last one, 17, it's a constant. Right? It looks like it doesn't have a variable in it or any exponents. Right? When we have that case, right, this one, I want you to think of it kind of like this. 17, that's the same thing as 17 times x to the 0th power. Right? Well, what is x to the 0th power? Right? This is 1. So 1 times 17, that's just 17. Okay? So this one, we would say this is a degree of 0, right? Or a 0th degree. Degree of 0. Okay? All right, so it's not hard, but you will hear us use this term. So you need to be familiar with what we mean when we say the degree of a polynomial. All right, I'd like you to write these 4 examples down and tell me what is the degree of all of these polynomials. Please pause and do that. Okay, all right, so here's the answers. This one is a 4th degree polynomial. 5 is a 4th degree. 6, this is a 1st degree. Right, and then this one is a 7th degree. And the last one, our constant, is a 0 degree, right? Or we could say degree of 0. Right? And again, also sometimes we call that, that's what happens when we have a constant. All right, something else you need to be familiar with is when we talk about a polynomial in standard form. All right, when you write a polynomial in standard form, you want to rewrite the terms in order from highest degree to lowest degree. All right, please pause and write that down in your notes. All right, now that you've written that down, let me give you an example here. All right, so all we want to do is put these terms in order, right? Here's 1 term, 2nd term, 3rd term, 4th term. We want to put those in order from highest degree to lowest degree. Right? Well, this part here has a degree of 3. This has a degree of 0. This has a degree of 5. This has a degree of 2. All right, so let's put it in order. The highest exponent is 5. So we would put that first. 5x to the 5th. The next part in order would be minus 4x cubed. Then it would be negative x squared, and then plus 7. Right? So again, we want to have the exponents in descending order from highest down to the lowest, right? And the constant should be at the end. Another term that you guys need to know is that when you write it in standard form, this right here, this coefficient, the front coefficient, is called the leading coefficient. Okay, the coefficient for the term with the highest power. Okay, so 5 would be our leading coefficient. Okay, last 2 examples. I would like you to pause and then write these polynomials in standard form, and then identify what the leading coefficient is. Pause and do that, please. All right, so for number 10, if we write this in standard form, it would be 8x to the 5th minus 6x cubed minus 17x squared plus 3. And then the leading coefficient would be 8. All right, and then the last one, if we write this in standard form, we would have x to the 4th plus 7x cubed minus x squared minus 3x plus 17. Right, and then our leading coefficient would be 1, right? Because I have a coefficient right here of 1, right? 1x to the 4th. All right, so this is the vocabulary you need to know. We will use this throughout our chapter.